Hello and welcome back to Mr. Powers Teaches Algebra. We are doing series. We just talked about what series are and the notation for partial sums. We have right here. And how we can take an explicit, and what we want to do today is talk about summation notation. And what that will do is if we're given a series, say, that looks like this, if we can see that it's an arithmetic sequence or a geometric sequence, if there's some kind of an explicit formula for the sequence being added, we can write it in a new way, a different way, and that is by using summation notation. And so here it is right off the bat. Here is a summation notation. I'm going to go ahead and go over this with you. We'll rewrite the one above with summation notation, then we'll do an example of a problem with summation notation. It's really easy, and it's just notation. It's just the way we write things. And it's a shortcut for repeated addition. But the addition, right, we're adding terms in a sequence again. We're doing a series. So this here, this notation, this expression represents the partial sum of a series. Okay, so the sum of the first n terms of a series can be expressed in summation notation as follows. So again, this would be another way, right? S sub n is sum of a sub k, where a sub k is some explicit formula, represents an explicit formula, from k equals 1 to k equals n. So we're going to add n terms, the first n terms in this case. K is called the index of the summation. 1 is the lower limit. And n, we could put n here, or we could put 5 or 10 in place of n. Okay? That's going to be the upper limit of the summation. All right? So, for example, going back to these guys, okay, we already know that the series in question, the terms can be represented using -1 plus 4n. So one way to represent this would be just the sum from k equals 1 to 1. So just 1, just one term. It's kind of a silly thing to do. Anyway, k equals 1 to 1 of -1 plus 4n. That's it. We could rewrite this one as the sum. Actually, k equals 1. What? No. So I need to replace my n with k over here. Apologize here. This would have to be k. So since I'm doing k over here, that's what that's going to be. Okay. So my sum of, again, -1 plus 4k k equals 1 to 2. That's this one. This one right here is the sum of -1 plus 4k from where k equals 1 to 3. Right? I have my first 3 terms of this sequence. That's what it means. And then S sub 4, I think you get the idea. I'll write it out really quick. This guy, the sum, k equals 1 to 4. We're adding the first 4 terms, -1 plus 4k. So there it is. That's how we could rewrite these. And then if I wanted to write the infinite one, now this is it's kind of a weird way to do it, but if we wanted to write it infinitely, this guy here, this guy we would write as the sum, or actually the limit, as we're real particular about this. The limit as n approaches infinity of the sum of -1 plus 4k as k equals 1 to n. That's the infinite series. We have to go from 1 to n, since it's not ending, and then say, hey, we're going to let n approach infinity out in the front. An improper way to do it would be to erase the n here and just write infinity and then get rid of this part. But that's not the right way to do it. But it would still get the point across. So, okay. Now that we got those out of the way, let's do an example. Hold on one second while I get an example in here. Okay. So evaluate the summation below. So how do we do this guy? This is really saying I'm going to do 7 times the sum here of the sequence, or the sum of 7 minus k, where k is 4 to 9. We're going to add those up. So it's like I'm going to have a 7 minus k plus another 7 minus k plus another 7 minus k plus another 7 minus k. Well, there we go. 4 to 9. That's going to be 6 of them. So 1, 2, 3, 4, 5, and 6. But each of these k's are going from 4 to 9. So the first one should really be a 4. The second one should really be a 5, because we're plugging in 5 now. The third one should be a 6. The fourth one should be a 7. The fifth one should be an 8. And the sixth one should be a 9. And there we go. I've changed my k's from 4 to 9. That's what this means, from 4 to 9. And then we're going to add up each of these sums. Here's, again, this is our 7 minus k, where k equals 4. 7 minus k, where k equals 5. 7 minus k, k equals 6. 7 minus k, k equals 7. And so on until k equals 9. And we add them up. That's literally what this means to do. So once we have this expression, and that 7 out front just means whatever we get for this adding, then multiply it by 7. Once we get that, we're done. And that's all it means. I think that's plenty for this example. So until next time, enjoy doing math.